Aging is a well-recognized global challenge. Today, not only are people living longer, but the fast pace of population aging around the world is also unprecedented. Scientists and academics are developing innovative solutions to improve the quality of life for the elderly and to promote healthy aging. Researchers at the University of Hong Kong are conducting cutting-edge research in gerontechnology to meet these challenges. Our researchers are actively pursuing technology transfer opportunities with industry to turn their findings into real applications. We're going to introduce 7 selected projects to you. They exemplify the knowledge exchange mission of HKU that aims to create impact and benefit society.
We're working on tissue engineering of cartilage. So we take the patient's bone marrow and get the stem cells, and then outside their body, we grow them into a cartilage, and then this cartilage will replace the damaged ones. We give stem cells biological and chemical signals so that we can guide them, differentiate them into cartilage cells. The unique part of our work is we provide a 3-dimensional environment so that they can grow into native-like cartilage tissue with the appropriate structural organization. One of the advantages of this technology is a simple, minimal invasive procedure can take bone marrow cells so that we don't need to hurt the patient's own cartilage. We hope this technology can be developed to treat early degeneration in the joints so that we can reduce the invasive joint replacement surgery for the elderly. In the long term, we hope the technology can revolutionize the way that we treat cartilage injuries, and this approach can be developed into personalized treatment for many other tissue injuries.
Osteoporosis is a growing problem worldwide where fragility in terms of your bones, especially in your hip and spine, lead to fractures. Our team is developing a kind of high-tech screw that holds together the fragments of bone, and the main difference in our case is that we're using a soft polymer. Prior to this, there have been no implants that really used a soft material. As part of our research into how bones fracture and break, we discovered that materials that were softer were able to maintain a really firm yet gentle hold on bones while they're healing. If we have a soft polymer, the polymer is able to expand and spread out the stress on the bone so that you don't end up having many small fractures that can eventually add up to a failure of the implant. So the goal of our work is to reduce the number of implant failures that are going to lead to a second surgery. So our dream is that in the future, even if more people have osteoporosis, the implants that they're getting are safer and more effective.
Menopause is a part of normal aging process. Aging women will suffer from menopausal syndromes, such as loss of bone mineral densities and poor memory. My research is looking for bioactive elements extracted from traditional Chinese medicine for relieving part of menopausal syndromes. I extract the bioactive protein from Chinese yam. Chinese yam is a common Chinese medicinal herb. It is an affordable and natural food. Chinese yam can increase the secretion of estrogen in women's ovaries, and without the side effects such as increase the risk of breast cancer and ovarian cancer. Actually, hormone replacement therapies is a common treatment for relieving menopausal syndromes. However, it has a lot of side effects. That's why Transcranial is a safer alternative to hormone replacement therapies. In 2016, we got the US patents based on our discovery. The clinical trials will be launched soon. We hope in the future our product can be developed as health supplements and drugs, which can help women who suffer from menopausal syndrome.
Wolfberry has been used as anti-aging agent in Chinese medicine for over 1,000 years. Scientists are now using wolfberry in search of multi-target medicines to treat different diseases, such as Alzheimer's disease, glaucoma. We use this concept, we apply wolfberry in our cell culture laboratory system. The key part of our research is to discover lithium berberrum polysaccharide, one of the fractions in wolfberry extract, can be used to cure Alzheimer's disease and glaucoma. In our experiment, we found that wolfberry extract can prevent neuronal loss triggered by the toxins in Alzheimer's disease, stop neurodegeneration in the retina, and can preserve eyesight. This means one stone can hit two birds. With our increasing aging populations, more and more people will suffer from Alzheimer's disease and glaucoma than ever before. We hope our discovery in wolfberry extract can help people to use more Chinese medicines in future to prevent neurodegeneration and to cure these two diseases.
A lot of elderly patients lost their hand function due to neurological disorders. With this soft robotic hand, we hope we can help those patients get rehabilitation and regain their quality of life. The existing robotic system uses rigid control, which is not flexible. But soft robotic hand use gas or food by a tube to make hand motion. The advantage of the soft robotic hand is with a friendly interface and adapt your motion and just follow the intention of the subject. We developed this soft robotic hand in the lab of Dr. Wang Zhen from mechanical engineering. The use of this new technology can help us to improve rehabilitation very well. It can train and rehab their hand much efficiently without any extra assistance. Even we can allow the patient to use chalk stick in future.
The elderly have a high chance of having swallowing problems, and this could be because they're aging, their muscles are deteriorating, and they could be having different chronic diseases such as strokes, Alzheimer's, and dementia. My first area of research is the use of repetitive transcranial magnetic stimulation to improve swallowing functions in stroke patients. So what it does is we have a big magnet on the head, and this magnet will create an electrical stimulation to the brain. And this electrical stimulation will trigger some brain activity. So by improving the brain activity, we hope to improve the swallowing functions as well. The other part of my research is to develop an app for swallowing and communication exercises. We believe this is the first app that will allow the elderly to practice these exercises at home. The advantages of this app is to allow those with difficulties in swallowing to practice at home and be more motivated to practice. And this will also minimize their contact time with the clinicians to save their money and time. As part of our wider research, we are also looking into the use of acupuncture to improve the swallowing in post-stroke patients. We hope this will help them to eat and drink more safely.
For a lot of patients suffer from the neurodegenerative and the trauma in the brain, they cannot get the day-and-day care in the hospital. That's why we developed this transcranial stimulator, which can be used in home by the patient themselves. This device is unique from others with a dry electrode and with a self-control system. It uses a nanoparticle coating to make the dry electrode. This can improve connectivity between the electrode and the surface of the brain. This stimulator is only moderation of the brain activity, so it can change the level of response, which can treat depression, cognitive disorders, and so on.